Hey there, folks. In this video, we are going to be talking about completing the square and solving quadratics by finding square roots. This will lead us into how to find solutions to quadratics when the answers might be irrational. Irrational is basically meaning it's not possible to write our answers as a fraction. So if we have an irrational number, an example of that might be like a rad 2. So if we have a radical that cannot simplify, we're going to see those pretty frequently. That's going to fall into the irrational category. So solving by square roots. This is what we're going to employ anytime we are missing the bx term. So essentially, if I have a quadratic equation as ax squared plus bx plus c, that middle term is not going to be there. So it's either going to be, we're either going to have an x squared and a c, or maybe both, but we will not have that linear factor there of the bx. All right, so my goal is to solve for x right here. That means I have to move some stuff around. Well, first thing I'm going to do is subtract that 10 to the other side. So now I'm going to have 4x squared equals 36. Again, I'm trying to solve for x, so I need to get rid of that 4, so I'll divide that out. So if I divide both sides by 4, I'll get x squared equals, let's see, that's 9. So now I've kind of peeled away all of the layers. I've gotten rid of everything connected to my x squared. So now I need to square root in order to get rid of my exponent here. A square root will nullify a squared. So those kind of cancel each other out. Then I'll be left with a plain old x. And I have to figure out what is the square root of 9. Well, square root of 9 is just 3. Well, here's where I have to be careful. There should be two answers, right? If it's x squared, I should expect up to two answers. And I've only produced one. The square root of 9 is 3, but it could also be negative 3. So to signify that, I'm going to put a plus or minus symbol in front of this. And what that indicates is I should be able to plug in 3 or negative 3 in for x, and this equation would still make sense. 3 squared is 9, times 4 is 36, plus 10, boom, 46. Negative 3 squared, still positive 9, times 4 is 36, plus 10, everything works out. All right, these next ones are pretty similar here. We'll go through number 2 because it's going to be slightly different, but the general flavor is going to be the same. First thing I want to do is add 5 to the other side. So I'll have 3x squared equals 30. I will divide out the 3, so I get x squared equals 10. I will then take the square root of each side. Well, shoot, I don't know the square root of 10, so I'm just going to leave that as plus or minus rad 10. That plus or minus symbol goes in front of the radical. In front of the radical. All right, number 3. If I subtract 16 to the other side, I'll have 3x squared equals, let's see, that'd be a negative 15. Dividing 3 from each side, I'll get negative 5. Then I have to take the square root of each side. And here's where we get into some issues. This is kind of off limits, right? So that's going to be no real solution. No real solutions. And what that indicates is that our graph will not have any x-intercepts. We will have no x-intercepts. Later on down the road, we're going to see that if you have a negative sign underneath the radical, we're actually going to write that with the letter I in front. And that I indicates that we have an imaginary number. So if you ever have a negative in front of the radical, that indicates an I for imaginary values. All right, let's see one of these down here, and then we'll move on down the way. Number 5, let's do number 5. I want to solve for x, but x is currently trapped inside these parentheses, and it's locked down by that squared. So first thing I need to do is move the 8 over. So I have x plus 1 quantity squared equals 8. And now I can get into the parentheses by getting rid of that squared. To do so, I'll take the square root of each side. So I have x plus 1 equals, let's see, square root of 8. It's going to be 2 point something. I don't know what it is exactly, so I'm just going to leave it as rad 8. And now to get x by itself, I just need to scooch that 1 to the other side. So I'd have x equals -1 plus or minus rad 8. And yes, rad 8 can break down. We can simplify that radical, but that is a conversation for a different day. All right, so that's going to help us lead into a process called completing the square. Completing the square is essentially a process in which we plug in a very specific value after a binomial consisting of x squared plus bx. So we're going to plug in a very strategic c value that allows us to write quadratics in a factored form, and this is what's called a perfect square trinomial, where we can write it as a perfect square trinomial. The way we do this is we have to generate what c value do I want here, and to get that c value, I'm going to take whatever my coefficient is on my x term, I'm going to chop it in half and square it. Since we're squaring it, it will always be a plus sign right here. All right, and then when we factor these, you'll have x plus or maybe x minus half of our b value, quantity squared. So first, we'll see what this looks like when we generate our c values. So let's see, x squared plus 8x, I'm going to chop that in half, and that's 4. And then to square that, I get 16. So if I saw a 16 here for c, this would be considered a perfect square trinomial, and I'd be able to write this as x plus 4 quantity squared. On number 2, I chop that in half and I get 1, and then I square it. Well, 1 squared is 1. So this is a perfect square trinomial now, and if I wanted to factor that, it would be x plus 1 quantity squared. Right here, if I chop -20 in half, that's going to be a -10. If I square that, squaring always makes it a positive, I'd get a positive 100. So then if I wanted to factor this, it would be x minus 10 quantity squared. See, 5, if I chop that in half, I don't feel like dealing with decimals today, so we'll just call that 5/2, 5 halves. If I square that, well, to square a fraction, just square the numerator, square the denominator, so that'd be 25/4. And this is what it would look like in factored form. Number 5, this is technically a -1 attached. Chop that in half is a -1/2. Square that. 1 squared is 1, 2 squared is 4, so plus 1/4. And then lastly, we'd have -100. We chop that in half. We get -50. We then square that, and we go on our merry little way. All right, so let's put that to work now to solve these. All right, we will do a handful of these examples, probably not all of them. Let's see here. Let's do number 4. We'll do number 3. For sure, number 6. And then depending on time, we might do a 4th one, just to see how it goes. All right. So first thing we're going to do is if I can divide out an a value from everything, I'm going to do that. So here, I notice they're all divisible by 2. So I'm going to divide everything by 2. And the reason for that is I like to see a plain old x squared. I don't like to see coefficients attached. So x squared plus 2x minus 1 equals, well, 0 divided by anything is just 2. So now I'm going to go through and I'm going to start solving this by completing the square. So first thing I want to do is isolate my a and b terms, and then I'm going to leave kind of like a little blank space right here. That means that 1 has to move. So I'm going to kick that 1 to the other side. 0 plus 1 is 1. Now here's where I have to be careful. I'm going to be filling in this blank space with some sort of number. Well, that number has to be going on the other side as well. Now, the area where I get this number is, just like we did on the previous page, I'm going to take half of 2, which is a positive 1, and then I'm going to square it. Well, 1 times 1 is just 1. So now, that left side of the equation can factor down into x plus 1 quantity squared. I've created a C value here that allows me to call this a perfect square trinomial so it factors down nicely. But whatever I add to one side, I have to be fair, I have to add that to the other. So on the other side, 1 plus 1, that gives me a 2. Well, this becomes a problem that we've been solving earlier, right? Square root each side. So I've got x plus 1 equals positive or negative rad 2. And then get x by itself, I'd move the 1 over, so negative 1 plus or minus the square root of 2. And that's about as pretty as I can make it. Sweet. All right, number 4. There's no number attached to the x squared, so that saves me a step. That's good news. First thing I want to do is move that 6 to the other side. So I have x squared plus 8x, and I'm going to leave a blank. And that'll equal negative 6, and I'll leave a blank over there. So I need to figure out what number goes here. Well, to do that, I chop my b value in half, which is 4, and then I square it. So I'm going to get 16. Whatever I do to one side, I have to do to the other. So now that I have that, I've completed the square over on the left-hand side. So this can factor down as a perfect square trinomial into x plus 4 quantity squared equals negative 6 plus 16. That would give me 10. So now we solve square root each side. Ooh, there we go, 10, not 16, my bad. Square root each side, so I get x plus 4 equals positive negative rad 10. And we move the 4 to the other side, so negative 4 plus or minus rad 10. Final answer. All right, last and final one in the interest of time we will do is number 6 here. So number 6, first thing, I'm seeing a 3 attached to this. I don't really like that. So I'm going to divide everything by 3 on both sides. Basically, I'm factoring that out, and I get to divide it off of the other side as well. So this is really x squared minus 4x plus 1 equals 0. I want to keep anything that has an x on the left side and kick the constant term over to the right side. And then I'm going to draw in my little blank spots here. Then I need to figure out what number goes in that blank. To do that, I chop this in half and I get negative 2. And I square it. When I square it, it's always positive. 2 squared is 4. Whatever I do to the one side, I have to do to the other. The left side factors down into x minus 2 quantity squared equals, let's see, negative 1 plus 4, that would be 3. I had to solve just like we've been doing. We'll square root each side. 3 does not have a pretty radical. Final answer here is going to be x equals 2 plus or minus rad 3. So that's the general gist of solving by completing the square. Some of you guys might prefer this. Some of you might prefer quadratic formula, which is coming down the pipeline. Either method is perfectly viable, so do whatever is comfortable for you. And as always, if you have any questions, do not hesitate to reach out and ask for help.